Hello and welcome, this is Math Athlete. Today we'll be discussing the topic of coordinate geometry once again, and today we'll be covering finding midpoints. But to start off with, let's recap a point we didn't finish off in the previous video. So let's just label these axes. So this is the y, and this is the x-axis, as we mentioned before. So if we label this the origin, which is where the y-axis and the x-axis intersect, so we should make this 2, let's make that 4, 6, 8, and 10. And let's only use one side of the axis. One quadrant of the axis. This is 2, 4, 6, 8, 10. And so we were talking about distance between midpoints. So say we had a point here, point A, and this was point B, and we wanted to work out the distance between them. So you wanted to work out the distance between them. We would say, now usually, as we said we would work. Actually, let's work in plane wise first. So not in diagonal. Let's work out parallel to the x-axis. Let's try and make it C. Okay, and let's label this C. Okay, so let's work out the distance between A to C. So as we know, we could have counted along the squares. We could have said 1, 2, 3, 4. Yeah, 4. So AC equals 4. But also, if we actually stated the x coordinates of both and subtracted them from each other, if we took, say we're talking about AC, we know that A has some x coordinate, let's call it x1, and B and has some y coordinate y1, and C also has coordinates x, some x, so let's say x2 and y2, and these x1 and x2 and can represent any number basically. In this case, A represents 3, 4. So that's the x coordinate. This is the y coordinate, which is over here. And for C, it is 7 and 4. 7 and 4. Now what you notice is if you took the second x coordinate, which is x2, and subtracted it by x1, you would have got the distance, which is exactly what it gave us. Now let's test it out. Let's do x2, which is 7, minus x1, which is 3, and it gives us 4. So now we have formulated what you call shortcut. So now we just plug in. So we will always refer to the ones with the 2's as the second letter. So usually A is always the one with the 1's. And so this also works with the y-axis. If you had a point here, let's use this kind of If we wanted to talk about this point here, which is point, oh, that changed color. Okay, doesn't matter. Anyway, if we wanted to talk about point D, we know that point D has coordinates 3, 8. So you go up 3 and you go along 8. And so that's its coordinates. So we'll say from A to D, what is the distance? A to D. So we will say that this is x2 and this is y2. So we would say, yeah, so we're talking about y-axis in this. Because if we done 3 minus 3, where is the A coordinate? So if we done 3 minus 3, it would be 0 horizontally, because it's only traveling vertically. So the distance between A to D, it will be y2 minus y1, which is 8 minus 4, which is 4. So the distance between AD is 4, and so we know, and we can also say that AD equals AC. Now that we have a AB, now we want to work out AB, we can use our Pythagoras, we can do, as we know, we can use this formula here, whereas green for our formulas. Oh yeah. So to work out a distance between 2 points, you would use this formula and this formula, and so it would look something like this. So to work out the distance between, you would have the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the side going up, and this is the side going horizontal. This is the side going vertically. So A to D or C to B, which are the same distance, and you have this one which is going horizontally. And this only applies, as we know, to right angle triangles. So if we try working this out, we would get 4 squared plus 4 squared, which is that's 16 and that's 16, so it'll be root 32. And so AB has the distance of root 32. Okay, so that was the recap. Let's go and start finding midpoints. Okay, so yeah, got rid of that screen. Y, this is X, and this is 0. We have to label these axes again. Okay, so we've labeled those axes. Okay, so say we have point A, no, say this is point B, this would be around point A. Say we have point A here, and we have point B here, and we have a line going across. So say I have the coordinates of point A and B, if we write them down, coordinates of point A. So point A has coordinates 2, 2, goes up by 2, goes across by 2, yeah. And point B has coordinates 8, 9. Yeah. So how about if I wanted to find out the midpoint of this line, the midpoint of AB, which is about here. How would I go about this? There's 2 ways you can go about this. First of all, we'll go the logical way. We could say to ourselves, you know, why don't we see how much it takes to go across here? So see how long it takes to go across here, and see how much it takes us to go up here. What is the distance? and then we just half each side. So we would half this, and we would half this height, and we'd probably get around here. Let's call this midpoint M. So what is we want to find out the coordinates of M. That's our that is our aim. Okay, so let's work out the distance. Let's give this C1. So AC, its distance would be, as we know, we'll use the formula x2 minus x1. In this case, x2 is 8. And it's basically like a number line. You know, you take the biggest number and you take the smallest number away. So 8 minus 2, and the distance is 6. And BC, 9 take away 2, which is 7. Okay, so now we know the distances. So we can actually half each of these to get to point M. So point M, we could say, if we point M is, its coordinates are basically half of AC. No, sorry. Yeah, we would say it is what point A was, which was 2 plus half of AC, comma, and then we'll say what it was 2 again. So we're referring to this 2 plus half BC. So in this case, M is 2 plus half of AC, which is 6, which is 3, comma, 2 plus half of BC. BC is 7, so it's 3.5 or 3.5. And so finally, M is 5 and 5.5. So that will be the coordinates of M. And if we look at it, if we draw lines to it, it should be here then. I underestimated. So yeah, exactly. So you go down and you'll notice that the midpoints of the coordinates of the midpoint M is 5 and 5.5, which is just between 5 and 6. Now, why are we doing this? We could have just read this off. Well, that's the same way we learned how to find the distance between points. We want to generate a formula. So if we wanted to generate a formula, or basically if we wanted to generate a formula or a general common rule, we want to view it in a algebraic perspective. So we would view this. I have to actually no, because we're going to do it in an algebraic perspective. We're not going to have values across the axes. So x. Okay. So say we're looking at point A and point B. A and B. I want this to have, yeah. And so point here is x1, y1, and this point here is also is now x2, y2. Now we're gonna show this at a perspective of it's basically an algebraic perspective. So A now has coordinates x1, y1, and B has coordinates x2, y2. Now why have we done this? So if we wanted to work out the coordinates, we realize. So as we mentioned, we realize. Sorry, I'm kind of pausing through the video so we save a bit of time. So realize that this distance here is y2 minus y1, and this distance here is x2 minus x1, as we realized before. So that means halfway, the midpoint, which is around here, midpoint midpoint M, which is around here, it should be halfway along. So to get to midpoint M, you would have to do half of x2, x1 plus where you already started from. So if we wanted the M, if we wanted the x coordinate of M, so the x coordinate of M, you have to put what you already started with, which was x1, plus half of x2 minus x1, and that would be your this would be your x coordinate of M only. This is your x coordinate, and you do the exact same thing for your y coordinate. You would have y1, which is where you originally started in the y-axis. If you started at the origin, then you wouldn't need to add. You wouldn't need to add this part. You just already start from 0. You're moving from 0 onto something else. But because you have already started, it's like you're in the middle of a destination, which is x1 and y1. So y1 plus half of y2 minus y1, and so that would be the coordinates of M. This is the algebraic perspective, and you'll see it'll become simpler as we go on. So now M can be rewritten as, so we have x1. How about we expand the bracket? How about we have half of x2 minus half of x1, and how about we view this all in one bracket? And also the same here, y1 plus half of y2 and minus half of y1, and let's also view this in its own bracket. Now you can do brackets within brackets as long as you put the right amount of brackets. So and apologies for that messed up bracket. So if we simplify this, we have x1 plus half of x minus half of x1. Now x1 minus half of x, so say x1 was 4, minus half of 4, minus a half times 4 would be minus 2. So it would be 4 minus 2, so it's half of the actual value. So now this becomes, if we pause it one more time, so now if we simplify this further, we'll have M, and we'll have a half x. It's like having a whole. You have 1 minus, no, sorry, why do I have a half? You have 1 minus a half, so you end up with a half again, which is exactly what we're doing here. You have a half, you have a whole, which is x1, minus half of x1, which is half x1, plus half x2, and then also you have the same thing happening here. You have a whole, which is y1 minus half y1. There's a y1 there. Let's fix that. That's y1. And then the double brackets, one bracket for this, one bracket for the whole coordinate. And the same thing happens here, half of y1 plus half of y2. And we can actually simplify this further, and this would be probably the last simplification. Now M has the coordinates of, we take out the half, so we have, or we can actually put them over the same denominator. So now we have x1 plus x2 over a half, and that would be your x coordinate. And now you have y1 plus y2 over 2 as well, and this will be your y coordinate, and this is your basic principle, and this is your formula for finding midpoints. So you just plug in values. So say A and B, let's plug in values. So A has coordinates. Oh, we haven't given it coordinates. Okay, we haven't given it values. Let's say this is 2 and this is 2. This is just rough. This is 6 and this is 6. I presume. I don't know. I'm guessing. And so we plug these in. Remember how A is the one and is the first one, B is the second one. So we'll have the values of x2 and y2. y2 and x2. Okay, just plug this in. So now M, if these are the values of A and B, M would have x1 of x1 here, which is 2, plus x2, which is 6, over 2, the common denominator 2, and y1, which is 2 here. I've chosen very simple numbers, plus 6 over 2. And so M, if we simplify this, 2 plus 6 is 8, divided by 2 is 4. So it's 4, 4. And so now this formula satisfies any numbers you plug in. It could be on the negative section, as long as you're good with negative numbers and acknowledge them, and you acknowledge the fact that they're negative. Hopefully it will work. This is not a doubt. There's no doubt in this. It will actually work. Anyway, this is finding midpoints, part of coordinate geometry. Thank you for watching. If you find these videos useful, subscribe. There's more videos to come. Please leave a rating and comment in the comment section below if you have any questions. Thank you for watching and goodbye.